I would like us to proceed and look at the types of radioactivity. Having defined radioactivity, now I would like us to look at the types. Look at the types of radioactivity. Types of radioactivity. So there are two types of radioactivity. One is called natural radioactivity. Natural radioactivity. Natural radioactivity. And the second one is called artificial. Artificial radioactivity. Artificial radioactivity. Now, let us start with natural radioactivity. Start with natural radioactivity. As the word dictates, natural radioactivity occurs when a radioactive nuclide disintegrate or split spontaneously, forming a new nuclide with emission of radiation and energy. So we say it occurs when a radioactive nuclide occurs on a radioactive. So you're talking about a radioactive nuclide, the one that is capable of undergoing radioactivity. So when a radioactive nuclide splits spontaneously into a new nuclide, with emission of radiation, and energy. And we said these radiations are emitted in form of particles. So when a radioactive nuclide splits by itself, that's why we talk about the word natural, because there is no external stimulus. So it splits spontaneously into a new nuclide and with emission of radiations and energy. That is called natural radioactivity. For example, we have a radioactive nuclide called uranium. Have uranium-238. This uranium undergoes radioactive decay. It splits spontaneously. It undergoes radioactive decay, forming another new nuclide called thorium, forming thorium-234. So as you can see, uranium is unstable. It will undergo radioactive decay. Radioactive decay is a spontaneous disintegration, forming a new nuclide completely called thorium-234. That is all about natural radioactivity. Now, let us look at what is artificial radioactivity. Artificial radioactivity. So artificial radioactivity, as the word dictates, it is artificial. It is from some influence. So we'd say that artificial radioactivity occurs when large stable nuclides, the key word is large and stable. Large stable nuclides, when you say it's a stable, it means it cannot undergo radioactivity it does not break up by itself without some force. So when large stable nuclides are bombarded by fast moving high energy particles. Now, in the process, when they have been bombarded, they split up into relatively smaller nuclei. With emission of radiation and particle. So in the process, they break up or split into relatively smaller nuclei, with emission of radiations and energy. So the key differences between natural radioactivity and artificial radioactivity is that artificial radioactivity, it is large stable. There are stable nuclides. They don't split by themselves unless they are bombarded by fast-moving high-energy particles. And once they have been bombarded, in that process, they split into relatively smaller nuclei with emission of radiations and energy. So that is called artificial radioactivity. Artificial radioactivity. Now, we have talked about emission of radiations. So it will be important if you are now to look, what are these radiations you're talking about? Let's now talk about types of radiations. Types of radiations. How many types of radiations do we have that we say they are emitted by any radioactive nuclide? So we would say that when a radioactive nuclide disintegrates, they emit three types of radiation. They emit when a radioactive nuclide disintegrates, they emit three types of radiations. Emit three types of radiations. One of these type of radiation is called alpha radiation. Call them alpha particles. So we said radiations are emitted in form of particles. So it's alpha particles, and it is denoted by a Greek letter alpha. The second type of radiation that is emitted is called beta particles. Beta particles. And it is denoted by a Greek letter beta. And that type of radiation that is emitted is called gamma. Gamma, call them gamma rays, and it is denoted by a Greek letter gamma. Greek letter gamma. Those are the three types of radiations that are emitted when a radioactive nuclide disintegrates. Now, I would like us now we look at the characteristics of each one of them. What are the characteristics of these radiations? Characteristics of radiations. And we're going to look at one at a time. Let us start with alpha. Start with alpha particle. Now, one of the characteristics of alpha particle is that alpha particle is a positively charged helium nuclei. A positively charged, this is a positively charged helium, positively charged helium nuclei, represented as so this is what we call alpha particle. It's a positively charged helium nuclei. When you say positively charged, it means, because you indicated a charge of positive 2 here, this is an atom of nucleus, which has already lost 2 electrons, and therefore we call it a nuclei, since it has already lost the 2 electrons that were in its energy level. So we call it a nuclei, because whatever we have here is only protons and neutrons. So this is a positively charged nuclei. Helium nuclei is what we call alpha particle. That's one of the characteristics. The second characteristic of alpha particle, as you can see, is that alpha particle has an electrical charge of 2 positive. Has an electrical charge of 2 positive, which is here. So it is positively charged, an electrical charge of 2 positive. And I would say that another characteristic would be, of the 3 types of radiation, alpha particles is the heaviest. It is the heaviest. Or particles, they are the heaviest of the three radiations. They are heaviest of the 3 radiations. They are the heaviest of the 3 radiations. These are the 3 characteristics of an alpha particle. Worth noting, this is the alpha particle. And an electrical charge of positive 2, and they are the heaviest of the 3 types of radiation. Now, let us go to the next type of radiation, beta particles. Got the next type of radiation called beta particles. We are still talking about characteristics of radiation. Please note that. Still talking about characteristics of radiations. characteristics of radiation. And now we are talking about the second one, which is beta particles. Now, beta particles, these are negatively charged particles. They are negatively charged particles. They are negatively charged particles represented as, that's the representation of a beta particle or a beta particle with a negative one here, and this is 0, this is an electron. They are actually electrons, but beta particles are not electrons from the outer energy levels. They are electrons that are formed from within the nucleus. They are electrons from within the nucleus, they are electrons from within the nucleus. It actually formed from within the nucleus. And how is it formed? A beta particle is formed when a neutron in the nucleus changes into a proton. When a neutron in the nucleus changes into a proton. Let us see the equation of the formation of this electron. So we are saying that when a neutron in the nucleus changes into a proton, it is going to release or produce an electron. As you can see, the equation is balanced. 1 plus 0, get 1. 1 plus negative 1, we get 0. This is a neutron that has changed to a proton. In the process of changing, it has produced an electron. The electron produced is the one we call beta particle. As you can see, but you should not make a mistake. The negative one here is not the atomic number. Actually, it is the electrical charge on this particular electron. So the negative one is not the atomic number. It is the electrical charge of the particle. And therefore, you can say one of the other characteristics of beta particle is that they have an electrical charge. Of negative 1. This is all about beta particle. So let us go to the next type of particle, which you call, or type of radiation, which you call gamma rays. Now, number 3, gamma rays. Gamma rays are high energy rays. And number 2, they do not have an electrical charge. Other particles are positively charged, beta particles are negatively charged, but gamma rays, they do not have any charge. They do not have an electrical charge. And another most important characteristic of gamma ray is that it is never emitted on its own. We can have alpha particles emitted. Once a radioactive nuclide has disintegrated, we can have an alpha particle emitted on its own. However, we shall never have a gamma rays emitted on its own. It actually accompanies the emission of either of the two. Either in the production or in the emission of alpha particles, a gamma ray is emitted. Or in the emission of a beta particles or beta ray, a gamma ray is emitted. So they are not emitted. On their own. They accompany emission of other particles. particles. That's all about gamma rays. It's all about gamma rays. So we have talked about, or rather we have discussed about the characteristics of these radiations, each one of them: alpha particles, beta particles, and gamma rays. We have said that alpha particles are positively charged, helium nuclei. Beta particles are negatively charged, and you have seen its representation in the form of an electron. And gamma rays, we have said they do not have an electrical charge. We have said they are high energy rays, and they are never emitted on their own. They accompany emission of other particles, either the emission of alpha particles or the emission of beta particles.